Welcome to Summarize Science. Today, we're looking at a fascinating paper where researchers put AI to the ultimate test, competing against top human students in a prestigious science competition. They took 5 of the most advanced large language models and had them sit for the International Astronomy and Astrophysics Olympiad, or IOA. This isn't just a multiple-choice quiz. The IOA is designed to test deep conceptual understanding and the complex reasoning skills that real astronomers use. The researchers used exams from 4 different years, ensuring the AIs faced a wide variety of challenging problems. They focused on the theory and data analysis sections, which don't require physical equipment like telescopes. So, how did the AIs perform on the theory exams? As you can see from this table, the results were absolutely stunning. The top-performing models, GPT-5 and Gemini 2.5 Pro, not only achieved scores high enough to earn gold medals, but they did so consistently. In fact, their performance was so strong that they often ranked in the top few positions out of hundreds of elite human participants. In several years, the AIs even scored higher than the number 1 ranked human student in the entire competition. This shows an incredible capability for solving complex physics and mathematics problems on paper. However, the story gets more complicated when we look at the data analysis exams. These tests require interpreting charts, reading plots, and extracting information from real-world data. While GPT-5 still performed exceptionally well, the scores of most other models dropped significantly, hinting at a major challenge for AI. To figure out why, the researchers conducted a deep error analysis, categorizing every single mistake the models made. They found a glaring and consistent weakness across all the AIs in what they call geometric and spatial reasoning. Astronomy is fundamentally about objects moving in 3D space, and it turns out that AI struggles to visualize this. Problems that required understanding the geometry of the celestial sphere or calculating angles in 3 dimensions, like this one involving a spherical triangle, consistently stumped the models. This chart breaks down all the points the AIs lost by error type. As you can see, the 2 biggest bars are conceptual errors and geometry/spatial visualization. Interestingly, they made very few simple calculation mistakes, meaning the problem isn't their math, but their fundamental grasp of physical space. This weakness also extends to interpreting complex scientific images. When asked to measure distances on these real images of a quasar, most models were off by as much as 20 to 50%. It's a visual interpretation task that's simple for humans, but remains incredibly difficult for current AI. So, let's recap the crucial findings. State-of-the-art AIs can achieve gold medal, superhuman performance on the theoretical side of astrophysics, rivaling the brightest young scientists on the planet. However, these same AIs have a critical blind spot when it comes to spatial reasoning, struggling to visualize problems in 3D or interpret complex visual data. What does this mean for the future? It means that while AIs are not ready to become fully autonomous research agents, they are poised to become incredibly powerful AI co-scientists. Researchers could use them to verify formulas or explore new theoretical ideas. But for now, the ability to truly visualize the cosmos and interpret its data remains a uniquely human skill. Thanks for watching Summarize Science.